So hello guys, welcome back to my YouTube channel. So today let's solve another LeetCode problem, which is delete nodes in a binary search tree. So this is a BST binary search tree question, which we have solved in the previous. So now it is another. The previous one which we solved, it was an easy problem, but now this is a medium. Difficulty level is a medium. So we will solve this problem today. So let's first read and understand what is given in the question, and then we will write down the code of it. Okay, then let's start. Given a root node reference of a binary search tree and a key, delete the node with the given key in the BST, return the root node reference, possibly updated of the BST. Basically, the deletion can be divided into two stages. Search for a node to remove, and if the node is found, delete the node. Okay, so what it is given to us, root node reference of a binary search tree. So this is our binary search tree, okay? And from here, the key which they have given is 3. In these 3, we have to remove from the binary search tree. So how we can remove it? So for that, we have to, first we have to traverse from root till the child, and we have to find out where is that 3. If the key is less than the root dot value, then we will go to the left hand side. This is the binary search tree property. So if the key value is greater than root dot value, so we know that we have to go to the right hand side of the root node. So by this way, we will go to the left side and right side, and then we will try to find out the key. If the key is available in the binary search key, then we will remove that node. Okay. And we have to remove also, and we have to give another node in the place of the deleted node. So you can see over here, 4 was there over here. After deletion, it has been given over here. So what we have to do is, after we have found out our key, then we have to give in that node one more node, which will be, it could be from this child node or it could be from this child node. Okay. So what we can do is we can take any of the values from here, 2 or 4. But we have to make sure that the BST properties are maintained. If the these 2 is not there, so we can straightforwardly write this key over here. And if 4 is not present over here, only 2 is there, then we can directly put 2 in the place of 3, and we will remove that, and 2 will be present over here. So if these two both are there, then what we have to do is we have to find out the minimum from the right subtree. So from this key, which is the right node. So this is the right, and from here we have to find out the minimum node value. So from here we can't see anything. So only 4 is there. So we have to give 4 in the place of 3. Suppose if there was value over here and 4 has a child node x and y, then from here we have to find out the minimum. From this node we have to find out the minimum value. So how we can find out? We know that the binary search key property, that from the left we will get the minimum value. So to find out the left, we have to go as left as possible to find out the minimum value, and that we will give in the place of 3. So by that way, we have to uh, replace the 3 with the another node value, which will be from the right side, and it will be a minimum. So how we will find out the minimum of it? By going to the left as possible. Okay. So, but over here in this example, we can see there is no the 4 doesn't have any child node. So we have to immediately we will put 4 in the place of 3. So that what we can do directly. Okay. But suppose if there was a value child 4 has a child node 2 or suppose any number x or y. So we have to give 3 a minimum value. The 4 left side we have to go because we know binary search tree has a 2 we have a property like on the left there is minimum value, so we have to go as left as possible, and then we have to replace that value minimum with that with the key. And if there is no left value, suppose if there are only right value, so what we can do, we have to still replace it with the minimum value. Okay, so if suppose y was there, so we will replace that with the minimum value. Okay, but over here you can't see over here. There is such we can't put over here maximum value like 7. Okay, if here the value was y, then we can put y over here. As we know, that is only the minimum value. So we have to replace it with the minimum value. So that's what we can do directly. So let's write down the code of it, and I will be explaining as I will write the code. Okay. So first, what we can do is we will write the base case. If not root, return root. Okay. If root is not present, then what we can do? We can simply return the root. Okay. And then we have to check if key is less than root dot val. Then what we can do is we have to go. We have to call delete node passing root dot means key is less. That means we have to go to root dot left, and pass the same key. Okay, and we will save it in the root dot left. This is we will search that and try to delete if it is present in the left side. We will try to delete. Okay, and the key is greater than root dot val. Okay, so what we can do over here, we have to search that node on the right hand side. So same will come as above. We did for the left. Now we will do for the right. We will call the delete node passing the root dot right on key. Okay. Else if not root dot left, then what we can do is we have to return root dot right. And if not root dot right, return root dot left. Okay. So what we are doing over here, we are checking if the root dot left is not there. So we will return root dot right in the place of this main root. That's what we have done over here. And next, we have to find out the minimum from the right subtree, right? Find the minimum from right subtree. So how we can find out? So we will write current is equal to current dot right. Okay. while current dot left current is equal to current dot left. Okay. Now what we will do, root dot well is equal to current dot well. And now we have to delete the node once again. So what we will do, shell dot delete node, and what we will ask is root dot and comma root dot well. Okay. Here we have root dot right is equal to. Okay. So this much is done, and in the last, after deleting that node and replacing it with the minimum right subtree, what we will do, we will finally return the root. Okay, in the output we want the root. So this is code is written, and let's run and see if there is some error. Oh, sorry. Your root will come. Root dot right is equal to. Now it will be working or not. Let's check. Yes, accepted. All the cases have been accepted, and let's submit. Okay, self dot delete node. Okay, so I will explain you once again what is written over here. Okay, so that you are able to understand. First of all, we are checking if root is present or not. If it is not present, then we are directly returning the root. As there is no key present in that root, so directly we will return that root. If the key is present and it is less than the root dot org, we have to check on the left hand side of the binary search tree. Okay, and we have to delete them. And if the key is greater than root dot org, we will check it on the left hand side and we will try to delete it. Okay, and next what we will be doing is we will be checking that if the root dot left is not there. If the root dot left is not there, we have to pass root dot right in the delete node in the main root. So that's what we are doing. And same way we will do for right. If root dot right is not there, then we will return the root dot left, so that we can do the same thing of searching the key on that node. Okay. Then what we are doing is have found out the that key, and then we have to find out the minimum from the right subtree. So how we will find out? We will take that root dot right and point it to the current, and then we will check if current dot left is there. If left is there, we will try to go as left as possible. Okay, and we will delete that. Okay, because now there will be 4 values. So we have to delete one. And which one we have to delete? The one which is on the root dot right side. Okay, so that we are trying to delete. and we are deleting it with this line, because now we have replaced this with the 4, and now we are having two 4 values, but we don't want two 4 values, we have to delete one. So we are deleting one by calling once again set.delete root. And then after deleting, we are calling the root. So this is what the code is. So hope you have understood the video, and if you have got something information from this video, so please like, share, and subscribe my channel. And till then, bye bye, take care, and I will be meeting you in the next video. Bye bye.